Today we're going to be talking about similar polygons. So a similar polygon have the same shape, but not necessarily the same size. So two polygons are similar if and only if their corresponding angles are congruent and corresponding side lengths are, the important word there is proportional. Okay? They don't have to be the same length, but they have to be proportional. What does have to be the same is their angle measures. So if you look right here, we kind of talked about this back way in the beginning of geometry. It said if angle A and angle W are the same, B and X are the same, Y and C are the same, and Z and D are the same. They all have to be the exact same measure. Now what we can do is we can say, all right, then if AB is 15 and WX is 5, okay, 15 divided by 5 is 3 over 1 or 3. Okay, same happens with BC over XY. 12 divided by 4 is 3. 7 and 21. 21 divided by 7 is 3. And then finally, 18 divided by 6 is also 3. So they are proportional. So these are considered similar polygons. So if I look at example 1, it says if FGH is similar to JKL, list all the pairs of congruent angles and write a proportion that relates the corresponding sides. So notice it says F and J are corresponding in the same spot. So that would mean that angle F is congruent to angle J. Angle G is congruent to angle K. And angle H is congruent to angle L. Then as a proportion, we could say that FG over JK is going to be the same as GH over KL, which is the same as FH over JL. Okay, so that's my proportion. They're all going to be proportionally equal to each other. Here's a guided practice problem. You try the same using these quadrilaterals NPQR and UBST. All right, scale factor. So what that proportion is it's called a scale factor. It's what we can multiply one side by to get the other, and vice versa. So if you see, if we're comparing AB to XY, 6 over 3 would be a scale factor of 2. If I was going the opposite, if I was going XY over AB, 3 over 6 is 1/2. So notice there's two different scale factors. There's one if you're going bigger, there's one if you're going smaller. So if I look at this one right here, example 2 has to do with the picture. It says Kuma wants to use the rectangular photo shown as the background for her computer desktop, but she needs to resize it. Determine whether the following rectangle images are similar. If so, write the similarity statement in scale factor. Explain your reasoning. So if these images are going to be similar, that means that side BC here is going to be similar to either FG or KL. So if I want to write that, I'd say BC has to be the same as, let's say, FG. Okay? Well, BC itself is 8, and FG is 12. So 8 over 12 would be the same as 2/3, because I can take a 4 out of both. Okay? So now, what we'd want to compare then would be DC and FG. Well, DC over FG would be the same as 10 over 14. Well, 10 over 14 reduces to, well, if I can take a 2 out of both of them, 5 over 7. Now, are my proportions here the same? They are not. So, these two images, ABCD and EFGH, are not similar. Let's look at then JKLM. So if I'm going to look at that one right there, okay, so BC would have to be similar to KL. Okay, so BC we said is 8, KL we said is 12. So 8 over 12 reduces to 2/3 again. Okay, good. So far that's good. Next one. CD would have to be the same as LM. Well, CD is 10, LM is 15. I can take a 5 out of both of those and I get 2/3. So are these proportions the same? They are. So that means that ABCD is similar to JKLM. So how could I write that? Well, the way we write similar is this. A, B, C, D is similar, we'll tilt it right there, as J, K, L, M. Now we got to figure out our scale factor. So to figure out our scale factor, what we're doing is we're going to say, well, if we're going from JKLM to ABCD, my scale factor would be 2/3. Because what am I multiplying 12 by to turn it into 8? Be 2/3. So my scale factor is 2/3. Here's a guided practice problem. You can try the same with these two triangles. So we're going to use similar figures now to find some missing value. So if I look right here, we know that A is similar to B. I know that angle C is similar to angle W. I know that angle D is similar, or is the same as angle Y. And I know that angle F is the same as angle Z. This helps us because now we can figure out that the sides are also congruent, or excuse me, the sides are also similar as well. So what we're going to do is we're going to say, all right, well, my missing side is FD, it's X. And the value that it corresponds with is ZY, so that's 10. So I'm going to say X over 10 is equal to its similar side. Because the triangles are proportional, we can figure that missing side out. Well, the side we know over here, CD, is 9, and we know that WY is 6. So I'm going to do 9 over 6. Now it's important that I set it up this way. You'll notice that in the big quadrilateral, I have the top numbers. So X and 9 are both in the same quadrilateral, so they're both on the top, X and 9. And in the smaller quadrilateral, I have 10 and 6. I have 10 and 6 here. So it's important that those are in the same spot. Now it's just a straight proportion problem. And to solve it, I cross multiply. So 6 times x is 6x. 9 times 10 is 9. To solve it, I divide both sides by 6. And I find that x is equal to 15. Good, we figured that out. Now, the next part, part B, says to find the value of y. Well, we can use the same proportion that we found before. We know that the y value that we're missing right here, it corresponds to FA. ZY, or ZB, is going to correspond to FA. So I can set my proportion up that way. So I'm going to say 3y minus 1, a small number on top, over 6 is going to be equal to 12 over 9. Now notice in this one I set it up differently. I looked at both quadrilaterals independently. I said 3y minus 1 over 6 is the same as 12 over 9. So now I set it up a different way. You'll notice it still sets up our proportion problem and still solves the same way. So 3y minus 1 times 9, well 3y times 9 is 27y minus 1 times 9 is 9, is equal to 6 times 12, which is 72. Straight algebra problem, I add 9 to both sides, and I get 27y is equal to 81. Divide both sides by 27, divide by 27, and you find that my y has a value of 3. Here's another guided practice problem. Use this the same to set up your proportions. Remember, there's 2 different ways to set up proportions. Both will give you the same right answer. Theorem 7.1 says perimeters of similar polygons. If ABCD is similar to JKLM, that means that their perimeters are also going to be proportional as well. So let's look at these ones right here. It says, if ABCDE is similar to PQRST, find the scale factor of ABCDE to PQRST and the perimeter of each polygon. Alright, so let's look at the information that we know. Well, I know that CD is 4, so AE also has to be 4. I know that AB is 8, which means that BC also has to be 8. So I can figure out the whole perimeter of this one right here. 8 plus 8, 16, plus 4, 20, plus 6, 26, plus 4, this has a perimeter of 30. Now down here, I don't know what my values are in PQRST, but I do know that RS is 3, and that corresponds with AE, which is 4. So what I can do is I can set up my proportion and say, okay, well, to figure out what each value is, it's going to be of the scale factor 3 over 4. 3 over 4. So now if I wanted to figure out PT, well, obviously that has to be 3. It's the same. Okay, I could take 4 times 3/4. It's going to be 3. Otherwise, the tick marks are the same. Now what I can do is I can say, well, what's 8 times 3/4? So I go to my calculator and I do 3/4 times 8. That's going to be 6. Same thing, that's going to be 6. Then the next one. 6 times 3/4. I go to my calculator. 6 times 3/4 ends up being 18 divided by 4, which is 4.5. Okay? So I add up all my sides. 6 plus 6 is 12, plus 3 is 15, plus 4 is 19.5, plus 3 is 22.5. And we can compare our perimeters and say, well, if you take 22.5 divided by 30, you'll never guess what it is. It's 3/4. Their perimeters also have to be the same. Now there's another way to do this one real quickly. What I could have done is I could have found the perimeter of this is 30. Okay? And said 30 is my perimeter. Over, I don't know the perimeter of this one. Let's say I don't look for any of the sides of this one. Okay? I don't know the perimeter. Over x. It has to be the same as, well, in the big side, or in the big quadrilateral, or pentagon, it had a value of 4 for AE, and in my little one, it had a value of 3. If I was to cross multiply, 30 times 3 is 90. 4 times x is 4x. Divided by 4, divided by 4, x equals 22.5. That's another way you can solve it, since the perimeters also have to be proportional. Here's the final guided practice problem. Set up very similar. Try this one.